Oh, yeah,
That'd
because
be-
that's 2a, okay. So, wouldn't it just be 4 square root 3?
So it's just 12 then?
Well, because you have to multiply
Wait,
square root
is 2
3,
square root 3, right?
You would?
right? Or maybe not.
Would you distribute it?
Okay, so then
How would you do 2 times 2 square root 3?
Would that just be 4 square root 3? Or?
Yeah. It'd just be 4
4 square root 3.
Okay.
Oh, it's that simple.
This is gonna take a long time.
So, the approximate radius is,
Okay, wait,
Four.
why do this right?
The radius is not.
I don't know,
You just
I
said
don't know.
squared.
The radius
5 is
is 2
equal,
times
just
a.
Yeah.
Yeah.
So isn't it?
No, you
Wait, so
keep the square
the
root. You
apothem,
just
which is
multiply
root
by
3,
two.
is the
Yes,
a root. No, is the
It
a
is
side.
2a.
No.
Or no, yeah, you're right.
It's the a
Wait,
side.
sorry.
So then,
The radius,
yeah, square root 3, square root 3, so it would just be 3.
3 squared, which would be 3, yeah.
Yeah, okay.
That's just
So-
gonna take
3
way
is
longer,
the
so
bottom
all
part.
you
no,
have to
3
do
is the
is
radius.
find 2a.
No,
And you know that
no.
a
6 is the radius.
So
Or
2 times by 2.
2 square root 3 is
You don't need to pay
4 square root 3?
That would
Yeah.
be
Wait, so is 4 square root 3?
So
Yeah.
3 would
So,
be
yeah, it
this.
would be 3.
So
Yeah.
the side,
Which one?
The side would be, the side would be
Really?
6, and then the radius would
Makes
be
negative 5 cents.
2 square root 3.
I get it.
Would-
Yeah, because 2 square root 3 is square root 3 times square root 3. No, it's not.
No, we have to do 2a.
Okay, I will.
Yeah.
So
The
it would be 2
apothem-
times
just
3.
can't-
So it'd be
I
2
just
root
can't
3.
write down the.
Yeah.
That would be
The radius.
this, like the,
Yeah.
Yeah.
this part would be 3 because it's square root 3 square root 3.
Wait, we're finding the side.
Yeah, and then you times it by 2.
2.
Because you
Wait,
cut it
what's
in half. Yeah, you
Side
cut
is
it,
six.
this is
Yeah.
3, so then you times it by 2 because,
Why is that 3?
because,
Oh, I
like
get
these
it, I'm
photos.
sorry.
These take a really long time.
and the drop
So it's just 6?
Yeah.
Yeah,
Okay.
thank you.
Because we figured out that it had to be 3, but then
But-
we were thinking of the radius.
Yeah.
It wasn't the radius. Too many 2's.
The next ones will be simple though, because it's a hexagon and the apothem will be
Oh, yeah.
Thank you.
No, I was gonna say a certain animal. And then it would have just been funny because you all would have been making the noise.
well, but there's like a French way to say it.
Yeah, that's true. That's like that. What was the It'll be good. Don't worry.
It was like Lauren.
This morning, my alarm,
It burns like,
my alarm clock was the fire
isn't
alarm.
it like keep or something?
Our fire alarm went off this morning.
Why would
I
you
don't
go really
know, I don't know if
late?
my brother's shower room was just a little steamier
know.
than usual, but it was like,
That was
so hot.
I'm like so
I was
like, I think
it's like
it's because I went to bed
6:15.
so late.
So I had to like,
smoke alarm or?
yeah,
Okay,
I had to like
that's the point.
stick my hand in front of the
Probably not good, but that's good.
thingy, yeah, I was
Is
like,
any of your
oh,
brothers in the basement?
Smoke alarm went off?
yeah, this morning.
Oh
His is, well, like there's one by the
Was he
bathroom and
taking
then
a
one by
shower or
my,
Does he,
Yeah.
does he take a shower upstairs?
yeah.
Oh, okay.
So
That
that was
happens when I
fun.
take a shower sometimes. Because I like to leave the door open and then the house gets really foggy.
Oh, yeah.
Mom's like, what did you do? Because she closed and shuts the door. Let's go over your work. today?
Maybe it was a doctor.
Yeah.
The lady helped a lot fix it, so that's good. Yeah.
Okay, number one, the ball before, what did you get? 150 after 25, so the change,
25.
negative 125, right?
Negative?
I just had 125.
I had my next one, that's me.
The ball should be the negative one and the skater would be the positive one because
the second
you would do
one
like
is
the
first.
after minus the before.
Okay.
And the ball has gotten slower
So, oh my God.
and the skater has gotten faster. So the skater before was 0 after 125, and so the change there would be 125, and they're both totals 250. And the velocity is what? 2.5. Good. And then the large fish before 45, after 36. Good. So the change negative 9. 36, yes, because what did you get for the velocity?
180. Oh, that's why. Wait, no, because
1B and 0.25.
Oh, that would be, never mind.
1.25?
Yeah.
Okay. And the small fish would be 0 before, after would be, what? 9, and so that increased by 9. And the totals for both then are 45, and the change is 0.
I'm so lost.
You what?
I'm so lost. Like, I kind of got the numbers, but like, some are off, and I'm like, what?
What's off?
I don't know. I guess it's probably more like, I don't know where I place it in my chart. Because it's like, I don't know.
For each one, you're calculating the momentum, which is going to be the mass times the velocity.
Right.
So each, for each object or whatever it is, for the before and after momentums, they're both going to be mass times velocity.
Okay. Alright, I'll just look at someone's chart afterwards as well.
So if, like in number 2, they gave you the mass of both,
Mm-hmm.
so you can use the masses for both of those in both of your momentum calculations for each. And they gave you the velocity of the large fish. That was before the collision. So that's how you can calculate the before collision momentum, and the small fish was at rest, so its velocity before the collision would be 0. I'm not sure where, all of your numbers on your chart look pretty good, so.
Well, I had changed them.
Oh, okay.
Okay.
I'm not sure where your question lies, I guess.
I think it's just like placing it. I got some wrong.
That's okay. I mean, but if you ask me, I can hopefully help you. Alright, the baseball before was what?
6.7.
Good, and after? 2.53. And so the momentum change is negative 4.22. You didn't. Sorry.
16.8.
That is the velocity. The velocity is 16.87. So then you have to use that to calculate the momentum after the collision, which for the baseball should be 0.15 times 16.875. 4.22 is the change
It is.
in momentum. Those are right.
Cause I don't have that one.
I don't know how you calculated it. How did you get this number?
I multiplied by the velocity. So I plugged this in with that. So like I did here for
No, you didn't, because that would give you 2.53.
Maybe I added that.
Okay.
Not that it's super bad.
Alright, so the catch event would be 0, and then 4.22, and then 4.22. Say hi. Number 4, the truck would be
1920. 200.
19,200. Before, after would be
3840.
3840, so the change is
Negative.
negative 15,360. The car before was what?
The walrus picture. Sorry.
I think you're asking what about the answer.
Oh,
What was the car before?
negative 14,400.
Negative 14,400. After was
960.
960, and so it changed also by 15,360. And the velocity was what?
0.8 meters per second east.
Good.
Very
robotic.
Yeah. Wait, okay. So
Okay.
I got the velocity rather than the moment. Cause I got 2.0. Cause I got 4.22, but where do you plug in the 2.5?
So once you get this, you put that in for V for both of these
Right.
to get the momentum after, which you can write down.
Right. Oh, you just write it in here.
This weekend or like beginning of next week. We'll get to it. My mom emailed it. She wanted on it. Yeah. Yesterday we had.
So then if you do 2.5, if you do that minus 6.75, you get 4.22. This one should be the negative one, this should be the positive.
Oh,
And I just
so this should be
like,
negative.
I'll just.
But this is decreasing, that one's going slower, so the change would be negative, and that one's going faster. Okay, other questions about that? How are you doing, Marina?
Can I see your chart?
Okay, then go ahead and get out your notes.
Oh, I see.
Whoops. I have the camera. I didn't have it pointing at the TV. What?
School bus. They always because they drop the kids off at the place if they're working.
Your handwriting is so
Call and drop the kids off.
pretty.
I still stand by my answer. I think they do both.
Okay, are we good with that then? Making more sense.
Yeah, okay, yeah. This is so
Yes.
easy. Yeah.
Okay, let me know.
Okay.
Alright, go ahead and get out your notes, please. Today we're gonna talk more like conceptually, not so much formula based. Okay, so if we have two objects, we know that if we have the mass before the collision times the velocity before the collision, and we sum those together, that will equal the mass after times the velocity after. And in all of these cases, the before the collision, one of the objects is not moving. So you would just have one mass before and one velocity before, because the other one is going to have a velocity of 0, so we're not concerned about that one. So this sort of is a simplified version of the, what do we call that equation? The momentum conservation equation that we talked about yesterday, and the day before. Because the other object, all of these examples, the other object will start with a velocity of 0. So, and then we'll have the mass after times the velocity after. Also, for all of these, they will be traveling together after the collision. So the velocity of both objects will be the same after the collision. Okay. So what we know is that the mass and velocity are inversely proportional, because if we have a really big velocity before and a smaller velocity after, then the mass will have to be bigger after in order to make them equal out. So they're inversely proportional. So an increase in mass would result in a decrease in velocity, which makes sense if we have a snowball, let's say. A bad example. If we have, like, you know, the cart with the bricks, so before the second brick is added, it's going to go slower. So the heavier something is, the less fast it will go if it's on level ground. And then, so also the velocity is very large when the mass is small, and the velocity is small when the mass is large. So they have an inverse relationship. So if you have joined NASA and you are doing your first spacewalk, you are outside the space shuttle when your fellow astronaut of approximately equal mass is moving towards you at 2 meters per second. If she collides with you and holds on to you, then how fast do you both move after the collision? So we have to consider how much the mass is being increased, and then the velocity will decrease by that same factor. So how much is the mass increasing by? By a factor of what? 2, because it says that you weigh about the same amount as your friend, or your mass is about the same amount as your friend. So if there's now one of you, and now you weigh the same, your mass is the same. Now there's 2 of you, your mass has increased by a factor of 2, it has doubled. And so therefore the velocity must decrease by a factor of 2. Or in other words, we divide the velocity by 2. So if originally your velocity was 2 meters per second, then now your velocity will be 0. What? What did you say? 1, yeah, 1.
I said 0.
I was confused. You got me confused.
Sorry.
So the new velocity would be 1, because the original was 2, and so now the new velocity then will be 1 meter per second. If, like me, you like to write things in equations and algebraically, then we can say the original mass, if we say our mass is just mass times the original velocity, will equal the new mass, which would be 2 times the original mass, times the new velocity, which we'll call v prime. And so then we can, if we're solving this for v prime, we can divide by 2m. And so we will see that the v prime, the new velocity, will equal the old velocity divided by 2. And the old velocity was 2. So 2 divided by 2 equals 1. Okay? Questions about that? Alright, okay, so a big fish is moving at 2 meters per second, encounters a small fish that is at rest, and the big fish swallows the smaller fish and continues in motion at a reduced speed. The big fish has 3 times the mass of the small fish. What is the speed of the big fish and the small fish? They will be together as one after the collision. So the mass has increased by a factor of, by a factor of what? Okay, so before the collision, the mass is going to be what?
3 times
3 what?
times the little fish.
3 times the mass of the small fish. So if we say m is going to be the mass of the small fish,